Yes, welcome all. In the previous class, we were describing the two-area load frequency control, and we described it. The Simulink model was described. Then this model, a complete state space model, was developed. Then it was solved for the performance analysis through the MATLAB program. And here, in this, just as a review, there was generator, turbine. This was a one control area. It was another control area, and this was an integrator. Two control area with the help of without integrator we studied. Then with integrator we studied, and we found on when there was no integrator, this integrator was not there in the secondary load frequency control. There is a primary automatic load frequency loop, there is secondary automatic load frequency loop. In this secondary automatic load frequency loop, if the integrator was not there, then there was a steady state error in the frequency. Means if there is a change in load, then after some time, after a few seconds, load become equal to the input was equal to the output, but with reduced frequency. Frequency was reduced. But with the help of integrator, we are able to restore the frequency again as the 50 Hertz. This was the case. And then we have also seen that we have seen that this is because of the feedback signal, because this from here, from this generator 1, or there is a frequency, this frequency is changed from here, this frequency change is given to this integrator, and with the help of integrator, a steady state error was removed, or we were able to restore the frequency. Now question arises that when this feedback signal can do better something in this control system, load frequency control in this system, then can we have the feedback from other places also? If we take the feedback from here, if we take the feedback from here, then what is this? What is the turbine output? If we take the feedback from the generator governor output, so if we take the feedback or feedback from here, if it is taken to this side, if feedback of turbine 2 of other area is given to the area 1, so what will be the effect of such feedback? To study that, we perform the modern control. We apply the modern control theory that our system, if our power system or the plant is like this, and in this plant the out x1, x2, x3, x5, xn are the system states. जैसे हमारे स्टेट में क्या था, हमारे केस में क्या था, x1 was the frequency, x2 was the change in power, x3 was the opening of the power, opening how much fuel was entering, then x4, x5, x6 the same in other area, then x7 was the tie line power, then x8 and x9. So there were system states, various system states in the power system. Now in place of taking the feedback 1, if we take the feedback from all the system states, x1, x2, x3 सभी से हमने एक feedback लिया, and with the help of some gain, we applied the gain, and this feedback is given to the input. Then we can see what is the, then we have to find out what is the effect of such feedback. Our system is x dot is equal to ax plus b, it is x dot. This you know. Is there any question in this? ये जो हमारा system है, this is known everybody is known to this system. इसके बारे में सबको idea है? What is this? Hello?
Yes sir.
ये सिस्टम आप सबको पता है. दिस इज x डॉट इज इक्वल टू ax प्लस bu बाई इज इक्वल टू cx. ये सिस्टम आपको सबको पता है. व्हाट इज दिस सिस्टम? In the previous classes we described that two area system or single area system that can be represented, that can be converted into the state space model, and this is the state space model of that.
Yes sir.
And where A was the system matrix, where size of this was 9 by 9 in our case, it was the B, and it is a control input, it is a control vector, and Y is the output. तो यही हमारा पावर सिस्टम था. उसमें हमने क्या, इसमें x1, x2 जो x9 सिस्टम स्टेट्स हैं, हर एक सिस्टम स्टेट से एक फीडबैक लिया, हर एक का अपना गेन एज्यूम किया, and then it is applied to the input. Then we will see what is the effect on the output. Okay, so if we see the effect of this output, now what will happen? So here now see U is the input. This U is the K1 X1 K2 X3 K3 X4 and K4 X4 Kn Xn like this. So the U is the K1 K2 K and X1 X2 Xn. अगर हमारा 9 है तो यह 9 हो जाएगा. तो ये हमारा इनपुट सिग्नल हो गया. मीन्स इनपुट हमने यहाँ दिया. Input now if input is equal to minus kx, where k is the this row matrix, and these are the system states. If you put u is equal to minus kx in this, if you put u is equal to minus kx in this equation here, u is equal to minus kx, so what will be here? U is equal to minus kx, so it is minus b kx. So here it will be now vkx, where if you take this x dot is equal to ax minus ax plus bu, in place of u we put like this. So if you take the xt as a common, then it is a minus bk xt. A minus bk, a is the 9x9 matrix and b is the 9y, it can be 9x2 or 9y1, whatever it may be. And this is in this case, if it is a 1y, u can be 2 inputs. It is not necessarily u is equal to 1. Here it can be u1 u2 also. In the two area system, you know u is not a 1, u is the 2 u1 u2. There are 2 input in the two area system, so you can be u1 u2. In that case, it is a 1 row and this is a so here u is equal to minus kx if you put, so a minus bk, this is another size of this will be again 9x9, so this will be afx. So our new system, in this case our new system will be the x dot is equal to afx. A means new, ax पहले क्या था ax plus bu, अब ये a चेंज हो गया, सिस्टम मैट्रिक्स हैज बीन चेंज. अब हमारा सिस्टम ये बन गया, if we take the feedback from all, तो ये सिस्टम बन गया. So now what will happen and what is our intention? ये हमारा सिस्टम बन गया. Now we want to improve the system. Improve means, improve का मतलब क्या है? If we want to improve the system, what is the meaning of this? Improvement अगर चाहते हैं तो क्या करना चाहते हैं एक्चुअली में? That thing should be clear in the mind. This was the system. अगर हम improve चाहते हैं, what is the meaning of this? If we want to improve का मतलब क्या है? जैसे ये हमारा डिस्टरबेंस आ रहा है, बिकॉज ऑफ द चेंज इन लोड द फ्रीक्वेंसी चेंजेस लाइक दिस. तो हम क्या चाहते हैं, ये सिस्टम हमारा ये सेटल्ड हो जाए. दिस शुड बी सेटल्ड, सेटलिंग टाइम शुड बी लेस. यहाँ सेटलिंग टाइम कितना है? 15 सेकंड है, बट वी वांट सेटलिंग शुड बी मिनिमम, सेटलिंग टाइम शुड बी लेस, सपोज इट शुड बी 5. तो ये हमारा सिस्टम यहाँ पे इस तरह यूनिफॉर्म हो जाना चाहिए. दूसरा क्या चाहते हैं, वी डोंट वांट दिस ओवरशूट एंड अंडरशूट, दिस शुड बी मिनिमाइज्ड. तो हम क्या करते हैं, ये जो ओवरशूट अंडरशूट है थ्रू आउट दिस शुड बी मिनिमाइज्ड. इफ दिस इज प्लस, इफ दिस इज माइनस, दिस इज प्लस, इफ यू टेक द स्क्वायर ऑफ दिस, तो बोथ विल बी इन वन डायरेक्शन, ऐसे हमारे हो जाएंगे. एंड सम ऑफ देम शुड बी इक्वल टू 0. सो दैट मींस दैट इज द मीनिंग ऑफ द इंप्रूवमेंट ऑफ द सिस्टम. हम चाहते हैं सिस्टम इंप्रूव हो. इसका मतलब क्या हुआ? इसका मतलब हुआ कि हमारा ये x ट्रांसपोज x क्या था? व्हाट इज x वाज x1 x2 x9, ये कॉलम मैट्रिक्स, एंड इट इज रो x ट्रांसपोज मीन रो मैट्रिक्स. इफ यू मल्टीप्लाई रो मैट्रिक्स विद द कॉलम मैट्रिक्स, व्हाट इज द मीनिंग? इट विल बी दी x1 स्क्वायर प्लस x2 स्क्वायर प्लस x3 स्क्वायर. इन दोनों का मल्टीप्लाई करेंगे तो ये आएगा x1 स्क्वायर, x2 स्क्वायर, x3 स्क्वायर, x4 स्क्वायर, xn स्क्वायर। एंड इंटीग्रेटिंग ऑल विद टाइम मींस इन ये जो x की वैल्यू है दिस इज चेंजिंग विद टाइम, सबका इंटीग्रेटिंग मींस समेशन ऑफ ऑल, दिस शुड बी मिनिमाइज्ड। Our intention should be, if this is minimized, we can say the system is improved one, performance is improved, settling time will be less, overshoot undershoot will be less. So this is called as a performance index. Okay, is there any question up to now? यहां तक किसी को कोई क्वेश्चन है? जगवीर, हेलो, मितेश,
Yes, sir.
यहां तक किसी को कोई क्वेश्चन है?
No, sir.
इसको हम इंप्रूव करना चाहते हैं, इट शुड बी लेस, इट शुड बी मिनिमाइज्ड। नाउ सेकंड थिंग इज, so this is nothing but here x transpose, okay, this can be written as a x transpose x. Now things is, if there are some system states x1, x2, x3, x9, and we know the importance of, from the practical experience we know the importance of frequency is more in comparison to the others, weightage is more than in, because you have seen the frequency signal, you have seen in the two area system the frequency signal has been taken and that frequency signal is given as a feedback, its impact is more in comparison to other system states. So if with the experience we understand, if some of the states has more weightage than the other, then we can include that weightage here. Then we can say here, say Q1 multiply here Q1, Q2, Q3, Qn, where Q1 can be weightage for x1, Q2 can be weightage for x2, Q3, this can be say 100, it can be say only 2, it can be say 50, it can be 10, depending upon that there can be a different weightage for each system states. And finally then we can say it can be written like this, x transpose qx, q is the weightage and q can be, since size, what is the size of this? Size of this is the 9 by 1, 1 by 9, x transpose means 1 by 9, size of this is 1 by 9 and size of this is a 9 by 1, so what should be size of this? It should be 9 by 9. So q can be like this, where it can be q1, q2, q3, qn, or if we know the one state has the one state affect the other state also, then these values, these off diagonal matrix may also have some values, some constant can be here also. In addition to that, if we do some performance after applying some performance, there are some constraints on the input also. Input means input हमारा U1 U2 है, input means how much opening, हमने input कितना change करना है. Suppose we want to open the fuel by some amount, but there is a limitation on the opening of the turbine valve, because there is a limit. We cannot say if it is a limit, minimum fuel it can supply, maximum limit it can supply, it has a constraints. So that constant if we take care of, so this can be U transpose RU. This is also a constant, we cannot go beyond that. So means after considering all system states should be minimized, considering the constraints, U transpose RU, what is, if you multiply this, it will be the U is the U1 U2, so it will be U1 square U2 square, or U, if some weightage is there R1 R2, so it will be U1 R1 square U2 R2 square. So this system is called the performance index. This performance index should be improved. Now how to improve the performance of the, how to improve the performance, उसको लिए हम क्या करते हैं, अगर किसी के सिस्टम को मिनिमाइज मींस जो हमारी ये है एरर मिनिमाइज हो, उसके लिए क्या करते हैं, मिनिमाइज और मैक्सिमाइज के लिए वी डिफाइन द लैग्रांज फंक्शन, एक लैग्रांज फंक्शन डिफाइन करते हैं एंड दैट शुड बी मिनिमाइज. तो लैग्रांज फंक्शन हियर इज डिफाइंड एज द, दिस इज परफॉर्मेंस इंडेक्स, ये हमारा मिनिमम हो. लैग्रांज फंक्शन क्या डिफाइन किया, दिस शुड बी मिनिमम विद द फॉलोइंग कंडीशन. ये हमारा सिस्टम है ax plus bu, x dot is equal to ax plus bu, or you can say x dot minus ax minus bu, it should be 0. So with this condition, from here this comes. So with this condition this should be minimized. So this is called as a Lagrange function, lambda, and this is called the lambda multiplying Lagrange multiplier. So and this Lagrange multiplier, it will be again a variable 2px. It will depend upon the system states. Let it be 2px. Now, to optimize this system, this is also called the optimal controller. So to optimize this system, what we do, ये जो Lagrange function है, it should be derivative of this function, partial derivative. Since L is the function of x, u, and lambda and time. This L is the function of all. So derivative of L, Lagrange function should be derivative of the partial derivative of L with respect to all variable. It should be 0. ये होता है हमारा मिनिमम मैक्सिमम मिनिमम निकालने के लिए यही होता है कि हमारा जो पार्शियल डेरिवेटिव है उसका 0 होना चाहिए. इफ द नंबर ऑफ वेरिएबल्स आर मोर देन partial derivative is taken. If number of variable is 1, then derivative is taken. तो हमारे सारे, so we will differentiate it. We will take the partial derivative L with respect to all these variables. तो इसके लिए हमने क्या किया, देखिए L, differentiate L with respect to lambda, differentiate L with respect to u, differentiate L with respect to x, then differentiate L with respect to x, then so this is done. So now differentiate L with respect to lambda. इसको with respect to lambda differentiate करेंगे. So this is, there is no lambda here, so the derivative of this, partial derivative this with respect to lambda will be 0. Partial derivative with respect to lambda will be lambda with respect to करेंगे तो यह ax plus bu minus x dot is equal to 0. So x dot, this is natural equation which we understand it is a system equation. Now differentiate L with respect to u. इसको with respect to u करेंगे तो देखिए this will be 0 and this is u transpose r u. ये क्या होगा, u transpose r means u square, so it will be 2ru. इसका 2ru हो गया. और ये lambda t derivative of this with respect to u, इसको करेंगे तो क्या v टांग, ये देखिए this is 0 और ये क्या है with respect to u, इसको करेंगे तो v आ गया. तो lambda transpose v. This equation is there. This is 0. From here we can find this u is equal to, this will go on this side, ये दूसरी साइड में जाएगा, lambda transpose v divided by 1/2r. तो ये बन गया u की वैल्यू आ गई है this. Now partial derivative of L with respect to x, इसको with respect to x करेंगे. ये क्या है, x स्क्वायर है, तो 2x क्यूब. इसको करेंगे with respect to u, पहले ये करेंगे partial lambda transpose lambda, then derivative of this, then derivative of this. So derivative of this is lambda transpose, और derivative of this with respect to x, इसको with respect to x करेंगे तो a आ जाएगा, तो lambda a. और फिर